Hello everyone. We are going to see today theory of interference fringes, and this is also known as Young's double slit experiment. Here in this experiment of interference, Young's has taken a source here. Near to this source is monochromatic source. Source of light. Yes, is here, and here a narrow slit is made. This narrow slit behaves like a source of monochromatic waves. Here, after that, one more obstacle is kept. And two holes S1 and S2 are made here, and the distance between both sources is taken 2D here in account. This both sources S1 and S2 is said here coherent sources, which produces monochromatic light of same frequency and constant phase difference. Let it is a screen which is kept capital D distance away from here. Right? Now, from the source, two waves meeting at point P, S1P and S2P. Let this point is O dash and it is O. Now see, we have here telescope which can move here on the screen. So the phenomena of interference is here. So remember, telescope is used to see the phenomena of interference, that is bright fringes and dark fringes formed on the screen. It is screen. Now see here how this interference patterns obtained. This point P is variable here on the screen, right, on both sides, and with this variable this telescope is adjusted. Telescope is moved up and down here in this case. Now see carefully one more thing here. Join these 2 points with a dotted line. O, this is OP here. Let this distance is XN. We want to see the phenomena of interference at point P. If the telescope is moved at point P, the bright fringe will form or dark bands will form. See here carefully, when light wave reach from source S1 and S2, then source S2, the distance traveled is S2P. This S2P takes longer path than S1P. See in the diagram. S2P travels extra path. Right? Due to this extra path, there is existence of path difference in both. Now see, when P is on point O dash, S1 O dash and S2 O dash is the same. So no path difference. Path difference appears when P is above 2 O dash or below 2 O dash. In that condition, at a particular situation, we may write path difference is equal to S2P minus S1P, because S2P is longer than S1P, and it can be represented by equation number 1. This is okay. Now see here in the diagram, 2D is the distance between two virtual sources, S1 and S2. 2D is a distance. Main source S is behind. When two put obstacle and two hole is made, then these two becomes virtual sources. So that is why it is known as a double slit experiment. Two slits are here available. Here in this, see very carefully. Let us make a wave front here, required to make. So from S1 we are drawing a perpendicular on S2P. Let this point is M. Perpendicular 90 degree. As such a way, it makes angle theta with it. Right? Now see very carefully here. S1M is called wave front by the Huygens concept. Now see very carefully here in it. When we move P down, M starts shifting towards S2. As P approaches O dash, M approaches to S2. Here this constructions implies that S1P is equal to MP. MP, this equal to here, so S2M is extra path. This implies that S2M is extra path traveled by ray of light emitting from source S2. And this extra path is called path difference. That is why this path difference can be written as difference is equal to S2M in equation 2. But one more thing is very important here to understand in the diagram. See this angle. Theta angle changes due to change this angle. As P approaches O dash, M approaches to S. So in both conditions theta becomes 0. When O dash approaches to P, S2 approaches to point M. So this both angle are equal. See in it. We are selecting a two triangle to determine the path difference here in this case. The triangle is in triangle S1 S2M. S1 S2M and this triangle O dash P. Triangle O dash P. In this both triangle, first of all we are going to select this triangle. Why this triangle? We want to see the value of sin theta. See in S1 S2 S1 S2M. For theta S2M is a perpendicular, as S1 S2 is the hypotenuse, then sin theta can be written as S2M by S1 S2. And sin theta, this implies that Sin theta is equal to S2m is this path difference, S2m path difference by S1 S2 distance between the virtual sources. This implies that path difference, that is S2m, S2m is equal to 2d sin theta, and it can be treated as equation number 3. Now we are going to do one more thing here. If we are going to take triangle this, and again we are going to obtain value of sin theta. Now see in this triangle O dash P, this sin theta is equal to perpendicular PO dash by hypotenuse OP. So one may write this sin theta is equal to PO dash by O dash. Since this PO dash we have taken in the diagram xn and xn by O dash, this sin theta. We are going to take one approximation. What is this approximation? We are going to take O dash is nearly equal to, this is hypotenuse OP, not O dash, OP, and it is O dash is equal to OP. We are going to take C. This is possible. Let me write theta is very small. If theta, since this distance is quite sufficient in comparison to it, more distance, larger distance than 2D, then, and theta is very small, then O dash and OP can be taken equal. Then sin theta speaks xn by OP is capital D. Here in this case, it can be written as equation number 4. Now see, when one compare equation 3 and equation 4, equation 3 and equation 4, then one may write path difference that is S2m is equal to 2d sin theta, and sin theta is xn by capital D. This is equation number 5. Condition of bright fringe or position of bright fringe. See, this is equation. Path difference is 2x, 2d xn by capital D. Now, what is the condition of bright fringe? Bright fringes are obtained when path difference that is S2m is integral multiple of n lambda, where n is equal to 0, 1, 2, 3, 4 and so on. N is equal to 0 means path difference 0, 1 means lambda, 2 means 2 lambda and so on. Now putting this value here, what is the path difference? 2d xn by capital D is equal to n lambda, where lambda is equal to wavelength of monochromatic light, which is used in experiment, young double slit experiment, and in young double slit experiment sodium light is used. So by that one may write xn is equal to n lambda capital D by 2d. Represent it as a equation number 6. Now let us see something we are going to calculate. First, if n is equal to 0, this equation 6 can be written as x0 is equal to 0. N is equal to 1. This is xn is equal to n is equal to 1. This becomes lambda capital D by 2d. N is equal to 2. x2 2 lambda d by 2d. Right? N is equal to 3. x3 is equal to 3 lambda capital D by 2d. Right? And so on. Now we are going to see spacing between two bright fringe. What is this? We can spacing between two bright fringe is known as beta. Two bright fringes, there is a dark fringe, so its fringe width it is called fringe width beta. It is x1 minus x0 or x2 minus x1 or x3 minus x2. When we subtracted it, this beta becomes only lambda capital D by 2d, and it can be represented as equation number 7. This is time to see the position of dark fringe, condition of dark fringe. Dark fringes are obtained when path difference, that is S2m, is equal to odd number multiple of half wavelength, that is 2n plus 1 lambda by 2, where n is whole number, that is 0, 1, 2, 3 and so on. Now we are knowing that this path difference is, here in this case we know that is xn by capital D is equal to, this is 2n plus 1 lambda by 2. By this relation one may write xn is equal to 2n plus 1 lambda, here capital D cross multiplication, when 2 will come 4 D here. Now xn, this equation is represented by equation number 8. Now what it do? We are going to see at various places the xn. If n is equal to 0, xn let x dash, n is equal to 0 means lambda capital D by 4d. n is equal to 1, this implies that x double dash, position of second bright fringe, n is equal to 1, then this becomes 3 lambda d by 4d. n is equal to 2, x triple dash, it is 2 2s are 4, 1 5, 5 lambda d by 4d it is. Now we are going to see what, that is spacing between two dark fringe. What is the spacing between two dark fringe? Between two dark fringe there is a bright fringe, and their spacing is known as fringe width. Right? So fringe width beta is equal to x triple dash minus x double dash or x double dash minus x dash, and after subtracting either by these two or these two, same thing obtained, that is lambda d by 2d. So beta is equal to lambda d by 2d. Either we are obtaining distance of bright fringe, spacing between two dark fringes, fringe width of bright fringe, or in first case dark fringe, both is the same. Diagram how the interference pattern will be obtained. To make an interference pattern, let us see the position of bright fringes, that is x0, x1 and x0 means center fringe is a position, first position of bright fringe. So come here in this x0 at the center. See, here is a bright fringe. Bright fringe we are getting by B. Thereafter x1 dark fringe on both sides. Dark, dark. Thereafter again of same width. Width will be same. Bright, bright. Then again dark. So alternatively bright and dark fringes are formed and this pattern is called interference pattern. In this interference pattern, the intensity distribution curve can be given like it. This is intensity distribution curve. We will see here in this graph. In it, in this side we will show path difference and above intensity. Maximum intensity I max, we are knowing A1 plus A2 whole square. Minimum intensity A1 minus A2 whole square, and fringe width is the same, that is given by formula lambda capital D by 2D. This is the characteristic of Young double slit experiment. So see in this very carefully. Lambda by 2, lambda, 3 lambda by 2. Now see, this is lambda by 2, lambda, 3 lambda by 2 and so on right side and in negative on left hand side. Since we know that center fringe is bright at 0 when path difference, intensity is maximum, it is at lambda by 2. At this situation, dark band minimum intensity. These are the position of dark bands, and bright bands are obtained when there is a lambda, maximum 2 lambda, 3 lambda, 4 lambda, same like as minus lambda, minus 2 lambda, minus 3 lambda, minus 4 lambda. When we join it with freehand, see carefully the diagram. So it is position of I max and this is position of I minimum. These are the position of bright fringes. B stand for bright fringes and this is for minimum dark position of dark bands. So this is whole about young double slit experiment. Thank you and have a nice day.